Okay, so we did anti-dihydroxylation. Now we're going to do Syn Dihydroxylation. So we use osmium tetroxide, and it's going to add across in a concerted fashion. So it's going to happen all at once. Let me get the oxygen, the electrons here are going to attack here. Oh, I meant to change to black. And the pi electrons are going to attack one of the oxygens. And some of these oxygens will go back to some of these electrons will go back to the osmium. And we'll end up with something that looks like this. They're both going to be up. It'll be oxygen, oxygen, osmium, and then we've got the osmium group is then removed with sodium sulfite or sodium bisulfite or MnO, and that removes the osmium and leaves the hydroxy in its place, and they are Syn, they're both up. Osmium tetroxide is very expensive, and so it's generally used with a co-reagent to regenerate it. Method 2 involves a cheaper compound, potassium permanganate, and the reaction, though, is very similar. I didn't get the black this time. We've got the pi bonds attacking the oxygen, these electrons going to the manganese, and then these electrons coming down to the carbon. And we make a similar circular structure. And again, they'll both be in the up position or they'll both be in the down position. The problem with using permanganate is that it will further oxidize to make a diol. So let's look at our examples here. We want to predict our products. So this is osmium tetroxide. It's going to result in Syn addition. So we're going to end up with the hydroxy in the up position here and in the up position here. The hydroxy will be on a dash and on a dash. Here, the hydroxy will be on a dash. Here, there is no stereochemistry, so it's just straight. There are two hydrogens at this position, so it's not chiral. And we'll have a dash, hydroxy there, and again, because this is an achiral carbon, we don't have any stereochemistry. Okay, so let's look at the last one. Here we're using potassium permanganate. Gone a little cheaper. We'll get this. And this compound is meso. And so there's the other one, this one, is the same compound. It's the same compound, and so there is no, you don't need to draw it. There's no point in drawing the same thing twice. Okay, so the next thing we'll do is we'll look at oxidative cleavage. We're getting close to the end.